Hello all, my name is Shashikaran Chandra and this is my project submission for the course Machine Learning Foundation for the Product Managers in Coursera. In this project, we will build a model in predicting the electrical energy output of a combined cycle power plant. So the data that we have provided has four independent variables and one target or dependent variable. The independent variables provided are the ambient temperature T, the exhaust vacuum V, the ambient pressure AP, and the relative humidity RH. And the dependent variable is the electrical energy output, which is the target that we are going to be predicting as part of this model building, our project in this case. So the dataset that has been provided as part of this project has about 9,500 rows of data. So I basically downloaded this file onto my PC where I have started doing my analysis. So I've split the data into a training set and test data using the random sampling. So 80% of the data that is provided, which is 9,500 rows, is categorized to be a training set, and 20% of the 9,500 rows is categorized as the test data, again using the random sampling. So before we jump into the deep dive analysis in the regression statistics or regression metrics, I wanted to kind of run run a simple scatter plot between the different independent variables and the dependent variables. So from the from the scatter plot that you see right where my cursor is, now I have scatter plot for between different independent variables and the respective dependent variables, p in the case, right? Now, from the scatter plot, it's clearly evident that each of the independent variables does have an influence on the dependent variable p. Now, we know that every one of those independent variables does have an influence, but we would also like to see which of these independent variables does have more influence than the others. So as it's clearly evident from this scatter plot, the temperature, that is T, and exhaust the AT, this is temperature, and exhaust vacuum V have a high negative correlation, which means a high influence on the dependent variable PE as opposed to the independent variables ambient pressure and relative humidity AP and RH. So before I conclude on what are the different variables I'm going to be using, or what are the different models I'll be using as part of my regression, I further wanted to perform a correlation matrix just to ensure that my findings from the scatter plot are indeed true, right? So I went ahead and did a scatter plot between the different independent variables and the dependent variable PE. As you can see here where my cursor is pointing, the RH has the lowest correlation, then comes from low to high the AP, and the V, which is ambient exhaust vacuum, and finally the highest correlation is the ambient temperature. So based on these findings, so I want based on these findings, um, I kind of chose to have three different models, right? Three different models, and to see which of this model is faring better, right? And also I have chosen to perform multilinear regression, since all of the independent variables and the dependent variables provided as part of the data are all in numeric in nature. So again, model 1 includes all of the independent variables. Model 2 includes the independent variable AT, V, and P, which is the ambient temperature, the exhaust vacuum, and ambient pressure. And finally, the model 3 includes the ambient temperature and exhaust vacuum as the independent variables, and these are the independent variables that have the highest correlation to the dependent variable PE, right? Now, before we further go into the actual numbers or actual regression output that we have gotten from three different models, I would like to kind of go over and give us a little background on what are the different what are the different attributes that we will be looking at, and in deciding which model is better over the others. So the attributes are R square, standard error, and F stat. Now obviously The higher the number of r square, which is explaining the amount of variation in y, the better the model is. But uh, which is probably true and not entirely true in some cases, because we are usually enamored by higher r square. However, we have to take into consideration that it is a descriptive statistics, and it alone by itself cannot define the model, define the model. So we have to take that into consideration, that r square alone cannot define the model is better or not. So we have to take that into combination of r square, the standard error, the f stat, in defining which model is more significance. Again, when we consider standard error, the lesser the value, the better the model is. Now, given that background, obviously, the other regression statistics that we look into is mean squared error, mean absolute error, and mean absolute percentage error. So with that background, I wanted to jump into the summary of the information that I have gotten by running a regression between three different models: model 1, model 2, and model 3. So as I've kind of laid out very in a simple tabular format, the r square for the model 1 is the highest among the three models, which is 92.9%, explaining the amount of variation in y by the regression itself. So that's a good number. But that itself is not going to give us an indication that this model is better. Now, if I kind of collate that with the standard error is 4.52. Again, if I compare that standard error against the three models, the standard error is the least. So again, our objective is to choose a model which is giving a higher r square and also a lower standard error. So in this case, model 1 is definitely our candidate for a better regression output. Now, with that given information, obviously we have calculated the MSE and MAE and MAPE as it's seen on the tabular format over here. Now, similarly, I have done the regression for model 2 and model 3, and between the three models, model 1 is the best performing model in this case. Now, with that background information that I have, so I ran a test regression on the 20% of the data that I have earlier split, and as you can see, my R square was 93.5% of the variation is explained in Y, and 4.36, which is the least, is the error. And the MSC, MAE, MAP are also the lower on the lower side. So this kind of gives me information that model 1 is better, and test is kind of aligning with the performance of the model 1. So that kind of concludes my project submission for the machine learning foundations for the product manager course in the Coursera. Thank you very much for listening to my video, and have a good day, and have a good day. Take care.